Hello, I received your question here. Several parts to it. Looks like you're working on part C. A nutrition wants to determine how much time nationally people spend eating and drinking. Suppose for a random sample of 1,047 people aged 15 or older, the mean amount of time spent eating or drinking is 1.25 hours, with a standard deviation of 0.72. Completes our A through D. And so I guess this part C, you want to determine and interpret a 95% confidence interval for the mean. And so I guess that, the answers only be here. Part C, the nutrition is 95% confident the mean amount of time, because it meant, it's based on the mean amount of time up here. So you need to figure out these two values, the lower bound and the upper bound. So N, the sample was 1,047 people. The sample mean is 1.25 hours, and the sample standard deviation is 0.72. The confidence interval is 95, and so alpha will be 1 minus it's 95%, which is 0.95. So alpha will be 1 minus 0.95, or 0.05. Alpha over 2 will be 0.025. The number of degrees of freedom is always n minus 1, so the sample is 1,047 minus 1, so the degrees of freedom will be 1,046. Now you need to probably read page 409 about degrees of freedom here. At the bottom of the page it comments that if the degrees of freedom are beyond 1,000, then when you go to table 6 on T distribution, you'll use the bottom row of numbers is what it tells you. So you go at the top of the column, you look at 0.025, and then you go to the last row in it, so the critical value is 1.96. And so again, since degrees of freedoms are beyond 1,000, you use the last row. So it's based, it generally use whatever number's closest to it. It's what they recommend if you read on this page. But if it's beyond 1,000, then you use the last row. So now, we have all the information. We just need to plug it into our formula. So I'll move this up here some. And so the formula, I guess, is x plus or minus t sub alpha over 2 times s over square root of n. And so that's the mean. So let's see, the sample mean was 1.25 hours, plus or minus, we got this 1.96 comes from the table 6. S, the sample standard deviation was 0.72, and then the number in the sample space was 1,047. So you just need to run this through your calculator. The plus will give you the upper bound, the minus will give you the lower bound. And so I went ahead and calculated those. When I punched it in my calculator, and let's see, for lower bound, what did I get? I think I got 1.206. They say go near 3 decimals, and then for that was the lower bound, and then the upper bound, I think I got 1.294. You just need to put these in the calculator. Hope that helps.